So yeah, I tried the stupid thing and it worked. Oh my god. Yeah, look at the tip of this soldering iron. This I made for desoldering SMDs, surface mount devices. And it worked. As ugly as it looks, it worked. So let me tell you a story. This is a 50-watt homemade soldering iron that turns 220 volts into just a few volts and a lot of amps. So it heats up the thin wire here, and this thicker wire doesn't heat up much. It heats up a little, but not much. So it heats up the thin wire. And the typical tip for soldering iron looks like this. So it's flat and it's basically a U shape. And I had limited success with this soldering, mostly desoldering. That's the problematic part, not soldering it back. I had the success desoldering SMDs with this by widening this gap here, right there, and bending it like this. So I can touch the SMD with these two curves of the tip. But the problem with this solution is that the tip starts heating up at the tip. That's how it's designed, at the tip. So this part burns out quickly. I desolder a few SMDs and it burns out and I have to replace the tip. So what I figured out without knowing any real electronics, what I figured that if I made this part thicker, the center, which heats up the most, if I made it thicker, then the rest of it would heat up quicker. Not the tip, just the two curvy parts that I need to desolder the SMD. So yeah, that's how I came up with this solution. So this is a standard tip, mostly, but it's bent differently. Hey, can you focus? But it's bent differently. It's not a good shape right now. It's just for testing. I didn't arrange it nicely, but it did the job. So this is a standard tip practically, like this. But the center is wider and I put on a piece of copper on it. So it won't heat up in the center, just starting here where the thin wire is. Only the thin wire heats up. Well, this heats up too, but not as much. It protects the center so it won't burn out. So that's what I did. And it heats up slightly slower than this solution. Slightly slower. But here it starts heating right where I need it. Exactly here. Because these points are halfway between this piece of copper and this piece of copper. So I have a double tip here. So yeah, the way I figure it, the current is, or amperage or whatever, the energy is power is split in two. So it makes sense that it will heat up twice as slowly. Yeah. What did I want to say about this? So that's how it works. I eliminated this point of failure where it always burns out. Now, another problem I have to solve here is the distance between the two bands. Because not all SMDs are the same size, and yeah, I can change the tip for every different size, or this is not flexible enough. This is just a standard copper wire. So I don't know what to do about that. But Maybe I will do some hinges with some bearings. I don't know, so it won't spark or heat up, or I have to think about it. But for now, I can show you how I desolder and solder back the SMD. First I tried a tiny little capacitor here. I just took it off in like 10 seconds. That's awesome. So let me show you how I do it. Here's a graphics card from the 2000s, maybe 1990s. Let's check. Is there a date on this? Yeah, here, 1997. Okay. Yeah, the 4 megabyte graphics card with fancy outputs and inputs. It had a VGA port here. Yeah, this was nice, with 4 megabytes of RAM. So yeah, let's zoom in and pick a part. I'll put this down and hold it in an angle because I have to reach with the soldering iron. Yeah, it won't be that easy. So I have to put something under it. Let me think. Plastic triangle to the rescue. And let's desolder. Oh, you can't see it. So let's try to desolder a small SMD. It's a bit too wide, so I will just bend the wire a bit. Now it's perfect. It will also hold it once it's desoldered. So now it's holding it. It touches the both sides. So when I press the button, the tip will start heating up. And let's see what happens. I also apply some force in one direction. So when the solder gets a little soft, then it will take off the SMD. This is a capacitor, I believe. So let's see. Oh boy. I think I kind of burned it. But the capacitor seems to be fine. Let's investigate. Can't you zoom, focus, do something, you stupid camera? It seems to be fine. There are some black marks here on the... No, it's not. It's not black, just very shiny. Oh, and the heat spreader is reflecting in it. It's not black, just shiny. Okay. Yeah, fooled by... Look, it's just shiny. Yeah. Okay, so now the capacitor is stuck on the tip, and to solder it back, I can just... what position was this in? Oh, it twisted a bit. Let's just force it back there somehow. Yeah, like that. But this doesn't really make any sense, because now that it's free, you can just start soldering one side and the other while pushing it down with this, and it will be back. You don't have to solder it with this double tip. But let's see how it goes. So steady hands and steady eyes. I can barely see. Oh boy. This is a bad idea. Kind of a bad idea. So I would have to use a different tip or a different iron for resoldering. It's in place. So I'm lucky that it doesn't heat up very fast. And when it doesn't heat up too fast, then I have some time to maneuver. So yeah, this wasn't in. I couldn't reach with the iron properly, but it's back and it's soldered properly in a slight angle, but that doesn't really matter with these SMDs. It's on there solidly, I can push on it, it doesn't budge. It's soldered on. Okay, so for soldering on it's not the best, but for removal, wow, it's such an amazing breakthrough for me, because I don't want to mess around with a hot air station or something stupid like that. I mean, not stupid, professional. With this, I can just put it there, 10 seconds to heat up, poof, I got it off, and I can solder something in its place. So what I will do mostly with this solution, not MacBooks and stuff, just a simple replacement on these LED light bulbs. So when I replace this, not this resistor, the other one, this is a 22 ohm resistor. Can't you focus, please? Please? Well, take my word for it, that's a 22 ohm resistor. And that measures the power or the voltage. I think the voltage that goes to the ring LED, the LEDs wired in series. So it measures the voltage on both ends. I mean on one end, yeah. I can't speak right now. It's night time. So it measures the voltage, and if you put a bigger value, now you can see it's 22. Now it focuses. Okay, it's 22 or 0. That's 22 ohms. So normally it's 22. Then the LEDs burn out quickly because they are at max brightness. That's how it works with the cheap stuff. And if I replace this with a 40 something, I replaced it with a 47 on another light bulb. With the 47, the consumption, I mean the power delivered to the LEDs drops to half. Normally it's 8.2 watts, and with the 47 ohm resistor, it drops to 4.2, 4.6, 4.2, I think. I'll have to check, but it's around 4, so to half. Yeah, to half. And then it increases the life of this bulb. So yeah, that's what I will be using the iron for, with this special tip. Just replacing this one resistor with a bigger one. And yeah, I will just take it off with this and take off resistors from other logic boards to put on here. So maybe I will take off a lot from a board from this. There are a lot of 33 ohm resistors here, quite a lot. I take them off and then one by one put them into LED bulbs, and it will reduce the power consumption by a third, maybe. Yeah, by a third, and it will significantly increase the life. Yeah, so that's what I'll do. I'll just take all of these off without a hot air station, without flux, without solder, without anything, just a 40-year-old homemade soldering iron and a special tip.